are two important considerations when building LLM applications. Yesterday, Anthropic has released new feature called prompt caching to address these two issues. It says, with this technique, the cost is reduced up to 90% and the latency is reduced up to 85% for long prompts. Okay. All right. So let's look at the pricing for the Claude Sonnet model. It has a context length of 200k tokens. But let's say we have a very large book and with 1 million tokens, and for easy calculations, let's say Claude allows 1 million tokens. Okay. So if we make one call, for the input, we get charged $3 for those 1 million tokens. Now, if we are making 10 calls, we would get charged $30, right? With the same document. Now, if it takes X time to process 1 million tokens for those 10 calls, it would take us 10x time. That's the latency, right? So with the prompt caching, the pricing model is this. So when we make the first call, which is when the caching happens, they charge a little extra, $3.75 per 1 million tokens. Okay. So for the first call, we get charged $3.75. But for the subsequent calls, since the prompt is already cached, they charge only 30 cents. So for the remaining 9 calls, we get charged about $2.7. So that comes out total $6. So the cost has reduced from $30 to just $6, right? And since the prompt is already cached, from call number 2, it wouldn't take as much time to process the context as it is in the first call because it is already being cached. Okay. So here they gave some examples as well. So if we have 1000 token, so the latency originally it's 11.5 seconds. It get reduced to just 2.4 seconds. So that's a reduction of 80%, and the cost is reduced by 90%. So they give a couple of other examples as well. Okay. So let's see how we use this feature. All right. So initialize Anthropic client, and here we are using Claude 3.5 Sonnet model, and we need a long context. So just downloading a book from the web from this Gutenberg web. The book name is this Pride and Prejudice. So we just download the book. It has total these 700,000 plus characters, which translate to 187,000 tokens. So that's almost close to the 200,000 token limits for this Claude Sonnet model. All right. Now, just for the demo purpose, if I were to use all these tokens, it would cost me some $5-6, right? So just for the demo, I'm using only the first 5,000 tokens. So this way, I'll be able to demonstrate how we can do the caching, but we wouldn't be able to see the improvement in latency. Okay, but I'll show you example for that as well. All right. So here we defined a function where we have the user content, which include the content of the book, right? With this 5,000 tokens. And then we are asking a simple question. What is the title of this book? So we invoke the model. We track the time. And from the response, we know it has taken us 1.91 milliseconds. And if you look at the tokens, earlier models, everything in here is counted as the number of tokens, right? But now it is broken down into the non-cached response as well as the cached response. Okay. So for the non-cached response, we have 17 tokens, which is simply what is the title of the book, only output the title. So it is not counting this content of the book towards the tokens. All right, and here we have the output response, which is simply the book name, output tokens 8. The book tokens which we want to cache, so those are counted towards these cached tokens. Okay, so you see here we have those 1300 tokens, and then since we are doing it the first time, the read tokens is 0. Okay, now for the subsequent calls, this should reverse, right? Because we are not caching anything new. So the creation tokens will be 0, and the read tokens will be 1354. Okay, so these 17 tokens, they get charged at $3 per million tokens, whereas for the first time, these tokens charged at some 3.75, but for the subsequent tasks, we get charged only 30 cents per million tokens for these cached tokens. All right, now how do we make use of this caching feature? We need to do two things. So the first one is here we mentioned this cache control type ephemeral, and the second thing we need to do is in the extra headers we need to specify that we are using the caching feature. Okay, so we need to do both the things to use this feature. All right, and then when we make the call a second time, the prompt is exactly the same, everything actually exactly the same, but this time it has taken slightly longer. We'll come to that in a second. As you can see, the tokens also remain the same, but this time, so the creation tokens is 0 because the prompt is already being cached, and the read tokens is the book tokens, but this time this get charged at a 10 times lesser price. Okay, now the reason why we did not see improvement in latency is because compared to here, so the latency it has two components to it, right? One, IO operations, and the second one is the actual processing of the tokens. Now because the number of tokens is just 5000, here the IO operations time is dominating over the token processing time. Usually the token processing time will be much longer, maybe 10 times, 100 times more than the IO operations time. Okay, since it is a very short context, it is dominated by IO operations, so that's why we didn't see the improvement here. But for the same book, as we saw before, this is their example. So as we discussed, it has over 187,000 tokens, right? Now if you look at for the first time, it has taken 21 seconds, and for the cached one, it took only 3 seconds. So that's a reduction of about 7 times in latency. Okay, all right. Two important considerations. The caching is available only for 5 minutes from the last call made. Okay, so if we are keep calling the model every 5 minutes, as long as we call, the cache will remain intact. But if there is a more than 5 minutes gap, we need to cache the prompt again. Okay, and the second thing is when we train an ML model, just like how we save the checkpoints, we can also have sort of checkpoints for the caching. So for example, let's say we are doing a very long conversation. Okay, is it here? It's not here. We are doing a very, very long conversation. So over the time, we built some chat history, right? So to the existing prompt, we want to add the chat history, and we want to create a new sort of checkpoint so that we can create a new cache, right? So we can create up to 4 caches. All right. That's all for this video. Thank you very much.